Hi, this is a video about 12th standard chemistry unit solutions. This is the second chapter in NCERT syllabus. Under solutions, in this video I am going to discuss about concepts of mixture, solution, concentration and units of concentration. So to start with, what is a mixture? Mixture. When two or more substances exist together, whether through physical or chemical means, then we call such a component mixture as a mixture. So this will have two or more components mixed together, where particles exist together. Under this we have two categories: homogeneous mixtures and heterogeneous mixtures. Homogeneous and heterogeneous mixtures. What is homogeneous mixture? In this case, we would say particles of one substance is uniformly distributed in the medium of another substance. I repeat, a homogeneous mixture is that in which particles of one substance are distributed uniformly in the medium of another substance. Then what is heterogeneous mixture? Where there is no uniform distribution. So there is no uniform distribution of particles of one substance in the medium of another substance. To give you an example, I would consider a system where water is taken in a beaker, to which I am adding a small amount of sugar. When a small amount of sugar is mixed in water, that system will become a homogeneous mixture because the particles of sugar are going to be distributed uniformly in water. That is sugar solution. In this case, I would consider a similar example where water is taken in a beaker, to which a small amount of sand is added. If sand is added into water, we can clearly identify the difference between sand and water in the mixture also. Sand is going to suspend in this. That means there is a difference or indication between the particles of sand and water. Such a mixture will be called heterogeneous mixture. I think it is easy to understand from these two examples. Sugar in water makes homogeneous mixture. Sand in water makes heterogeneous mixture. In first case, there is a uniform distribution of sugar particles in water. In second case, there is no uniform distribution. Particles of sand are settled in the medium of water. So it is a heterogeneous mixture. After understanding what is mixture, the next point is solution. If you understand mixture properly, the statement for solution or definition of solution becomes very easy, because a homogeneous mixture of two or more components itself is called a solution. The definition of solution is very simple. A homogeneous mixture of two or more components is a solution. And those components can be solid mixed with a liquid, liquid mixed in a liquid, gas mixed in a liquid, and so on. So all those mixtures where there is a homogeneous, that is uniform distribution of particles of one substance in the medium of another substance, will be called a solution. I hope the concept of solution is clear so far. Let us continue further. Solution and the types, and what are the components or constituents present in a solution, a simple solution. There are different points to understand here. A solution is said to be made up of mixture of solute and solvent. Once again, when I say mixture, please understand this will be a homogeneous mixture. So there is one component called solute and another component called solvent. If these two are homogeneously mixed, will become a solution. Then how to identify which is solute, which is solvent? In my previous example where I had written sugar mixed in water, I said it is a solution, homogeneous mixture. So I'll consider the same mixture once again. Water in a beaker. To this, I'm adding a small amount of sugar. Okay. If this becomes a solution, then which is solute and which is solvent in the system? Very simple. We all understand this easily. Sugar is solute. Water is solvent. Then what are the definitions? What is a solute? What is a solvent then? We have 2-3 different types of explanations given about solute and solvent. The first one is relative explanation or definition. It's like solute is that substance which is dissolved in solvent. That means using the concept of solvent we are explaining what is solute. Solute is that substance which is dissolved in solvent. Then what is solvent? Solvent is that substance in which solute is dissolved. It's a simple explanation. There is a second type of explanation also, where after mixing solute in solvent, if the solution appears like one of the two components, then that component becomes solvent. A little bit confusing to understand. Let me explain with the example itself. If I mix sugar in water, the sugar solution appears more like water than like sugar. I hope you can understand this. Sugar mixed in water makes sugar solution. Sugar solution appears more like water than like sugar. So water becomes solvent. Based on the appearance, we can say which is solvent and the other substance becomes solute. I think this is a bit confusing. The third method of defining solute and solvent will be very easy, which is better to consider. In this case, we say the component present in smaller proportion in the solution is solute. The component present in smaller proportion is solute. Obviously, the component present in large proportion or larger proportion will be called as solvent. I hope this statement will be better. Please keep the third method of giving definition. What is a solute? Say in a solution, the component present in smaller proportion is a solute and the component present in larger proportion is a solvent. Based on these two, we say what are solute and solvent and it makes a solution. So solution is a homogeneous mixture of solute and solvent. I hope the concept of solution is also clear. Let us continue further. What is concentration? What is the concentration of a solution? Okay. Most of the times we come across words such as strength, concentration, dilute. These terms are directly related to the term concentration. I think we have come across the words such as the coffee is very strong. When do you say the coffee is very strong? Whether the coffee powder is more than required will become a strong solution. That means strong word refers to concentration. You may also say if you want to reduce that strength of the coffee, you will add a little more milk. The process is called dilution. So the word dilution also refers to concentration. So let us understand what is concentration now. Okay, to understand this better, I will consider 3 different systems where I have 1 liter water in a beaker and again I have 1 liter water in another beaker and I have one more beaker little bigger which has 2 liter water. To these systems, in first case I am adding 10 gram sugar. In second case I am adding 20 gram sugar. In third case I am adding 10 gram sugar. Okay, please understand these. 10 gram sugar in 1 liter, 20 gram sugar in 1 liter, 10 gram sugar in 2 liters. And I would call these systems as A, B and C. If I ask a question, among A and B, which is more concentrated? I know you will give a quick answer that B is more concentrated than A. Because we know that sweetness will be more in second case than in the first case. Of course, sweetness is also a measure of concentration. When 20 gram sugar is present, we would easily say this solution will be more concentrated than A. Now, if my second question is, among A and C, which is more concentrated? Though 10 gram sugar are present, the amount of water is doubled here in C. That means the concentration of C must be lower. Therefore, we would say A is more concentrated than C. Now, what is the meaning here overall? Very simple. When the amount of solute is increased, we are saying concentration is increasing. When the solute is increased, concentration increased. But when the solvent is increased, the concentration decreased. That means concentration is directly depending upon the amount of solute that we have taken. And it is inversely depending upon the amount of solvent that we have taken. So, can we say the definition like this? What is concentration of a solution? It is the amount of solute present in the given volume of a solvent. The amount of solute present in the given volume of a solvent is called concentration of a solution. I am giving you the definition once again. Please try to follow this. Concentration is amount of solute present in given volume of solvent. I am particularly using this word volume here because I want to derive an SI unit for this concentration. The SI unit becomes very simple. See, amount of solute, which is number of moles, and volume of solvent, which is liter. Moles per liter becomes the unit of concentration. Very simple. Please remember this unit. Mole per liter is the standard unit of concentration. I hope you understood what is concentration. Now we will see the different units of concentration. What are the different units that we use to express the concentration of different solutions? Okay. After understanding what is the meaning of concentration, let's move on to this concept, that is units of concentration. There are different units of expressing concentration of solution. For example, mass percentage. Mass percentage. We have a unit called volume percentage. We also know mass volume percentage. Then we know molarity. Then we have normality. Then we have molality and mole fraction. Mole fraction. So these are the different units. We also have other units such as ppm, parts per million, and so on. Anyway, mass percentage, volume percentage, mass volume percentage, molarity, normality, molality, mole fraction. These are the different units of concentration that I am going to discuss today. Mass percentage, what is this? The very word itself indicates here. It's a simple explanation. Percentage, we know how much is present out of 100. Very simple. Mass percentage is mass of solute by mass of solution into 100. This is the definition. Mass of solute by mass of solution into 100. Yes, here there is a small mistake that we usually do. When we say mass of solution, please don't understand this as mass of solvent. It is a sum of masses of solvent and solute together. That means if I say 5 gram solute is mixed in 10 gram solvent, solution mass becomes 15 gram. Please understand this. And the percentage will be 5 out of 15, not 5 out of 10. Okay, solute is 5 gram, solvent is 10 gram. Since we are measuring masses here, do not ignore the 5 gram solute here in solution. Therefore, we have to add these two to get mass of solution, which is 15 gram. So the mass percentage becomes 5 by 15 into 100. I hope the thing is clear. Okay. Next, let us see what is volume percentage. Volume percentage. This is volume of solute by volume of solution into 100. So in this case, if the solute itself is a liquid, it will be useful. If the solute is a liquid, then it will be useful. Volume of solute by volume of solution into 100 makes it volume percentage. Then what is mass volume percentage? By this time you would have understood what is mass volume percentage, because you know what is mass percentage. Mass by mass is mass percentage. Volume by volume is volume percentage. Then what is mass volume percentage? Very nice. This is mass of solute by volume of solution into 100. Okay. Only in this case you may ignore the volume of solute while taking volume of solution. For example, here I say 5 gram solute is dissolved in 100 cm cube water. Okay, if I say 5 gram solute is dissolved in 100 cm cube of water, 100 cm cube is volume of solvent, 5 gram is mass of solute. Here you need not add 5 to 100 to consider volume of solution. It will remain as 5 divided by 100 only, because 100 is volume. Do not add mass to volume to calculate the volume percentage, mass volume percentage. In the other two cases, we have to add the value of solute and the value of solvent. In case of mass percentage, mass of solute plus solvent will be solution. Similarly, volume of solute and volume of solvent will make a solution. Here, volume of solution means you need not add the mass of solute to this. Do not add mass of solute. It will only be volume of solution, which is nothing but volume of solvent. I hope you can understand this. Volume of solution will be approximately same as volume of solvent, because mass of solute is considered, which is not going to change the volume so much, not considerably changed. Okay, so this is mass volume percentage. Okay, let's see what is molarity. Molarity, a very famous unit, very important unit. Molarity, it means number of moles of solute dissolved in 1 liter of solvent. Number of moles of solute dissolved in 1 liter of solvent is molarity. And molarity, we can write it as N by V, number of moles by volume in liter. Be careful while calculating, it must be in liter. Otherwise, convert this. Number of moles is mass by molecular mass. Volume in liter, so I will consider V here. If it is given in centimeter cube, multiply mass into 1000. So molarity will be W into 1000 by M into V. Please note this formula. It is useful to calculate numerical problems. We will calculate numerical problems further in other videos, the next parts. So molarity is given like this. Molarity is mass into 1000 by molecular mass into volume. Please don't be confused between this M and this M. Okay, I'll make a small change here. I'll call it as mu otherwise, to just give a difference between molarity and molecular mass. This mu is molecular mass. There is no standard symbol such as mu. Just to give a difference between m and m here, I have made it mu. Okay, this is molarity